Hello, everyone. Welcome for the next one, right? So, final revision. Time to now, you know, quickly apply our concepts into questions which we can expect. Here we go, right? Without further ado, this is high time, right? No time to waste, not even a single minute, right? Let's get into the show. Let's get into the problem solving. Okay, so here we go. Just to remind you, that CDC4 is open till tomorrow for registrations, right? So therefore, watch out for this, right? It's one of the many important ways to get geared up for the exam, right? So just check out the details. Last day to register is tomorrow, right? CDC4. Okay, let's start. Here we go. Right. In the 1999 general elections, 60% voters turned up, whereas in 2024, 55% voters turned up. So percentage dropped. If the number of votes cast in 2024 was 10% more than that in 1999, number of voters increased. However, percentage of voters decreased because base value has changed. Then the number of voters increased over the duration by how much percentage? Right. So obviously, since voters have increased despite the percentage of voters being decreased, means the base value must have substantially increased, right? So you have to relate basically the total population of voters in the two election years, right? So from 1999, let's say the total population is some 100K of voters, not total population of the country, but total voters, right? Is some 100K. So how many turned up? How many actually gave their votes? The voters who turned up, right? That was good, Prabhakar. He is very much alert. Thank you, Prabhakar. Good. Right. So 60K, right? 60K. Now, what we know is that the number of votes increased by 10%. So if 60K votes 60K votes were cast in 1999, then we know that in 2024, 10% more votes were cast. So this was 66K. Now, this 66K, we know whatever total is here, it is 55% of that total. So therefore, to find that total, that is the main objective, this 66K is 55% of the total population. So 11 cancels, 5% is 6. So 100% is 5% is 6K. So 5 into 20 is 100K. 100% is 20 into 6, 120K. It means the number of voters have increased from 100K to 120K, means that's a 20% increase, right? So many ways to do this question. This is how I would navigate through, right? 100, 60, 66, 120, right? Perfect. Good, 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 good. Everybody is in good mood, right? Happy to see your response. Let's see the next one. Okay, so since you're trying, let me give you a minute to try this, right? Let me give you a minute. Okay, right. So I've given you some head start. So if you're able to finish this, let me know. What I will do is I know the speech of all the three people. Can I say all of them start from the same point in the same direction? And eventually, since it is given that B starts to after A and both B and C overtaking A at the same time, if you understand this visually, that A and B and C, they started from a common point, not at the same time, but at least the starting point was common, and eventually they were all together at a common point somewhere down the line. at the same time. So effectively, they have all covered the same distance, right? So I can use the distance is constant concept, right? I can use the concept that when distance is fixed, speed and time vary inversely. All of them have covered the same distance, if you understand this, right? So therefore, this question can be done very beautifully like this, that their speeds and time are going to be in the inverse proportion. So we know their speeds are respectively 30, 40, 50. So I'll just write the ratio 3 is to 4 is to 5. So since everybody is covering the same distance eventually, so their times must be, the time taken by them to cover the same distance must be in the inverse ratio, which is 1 by 3 is to 1 by 4 is to 1 by 5, which can be further simplified in the integer form if I multiply with the common LCM, which is 60, right? So the time taken should be in the ratio of 60 by 320 is to 60 by 415 is to 60 by 512, right? So therefore, B starts 2 hours after A, means the time difference between A and B is of 2 hours or 120 minutes. So this gap right now is 5. This 5 needs to become 120. So 5 into 24 would be 120. So you need to multiply all these values with 24 to state the actual time taken, right? So the actual time taken is 24 into 24, 80 minutes for A, 24 into 15, which is 360 minutes for B. That accounts for the 120-minute time gap, and 24 into 12, which would be 288, right? So therefore, how many minutes after A did C start? 480 minus 288, 192. Prabhakar is there with his answer as usual. Good evening, Ritu, everyone, right? Let's make use of this session to practice, right? I will only give you as much requisite time for trying, right? So let's see the next one. Perfect. Any doubts you can ask, any confusion you can ask, right? Many ways to do this question, but the ratio approach is the best way. So search for, if time is fixed, distance and speed are inversely proportional, right? If speed is constant, then time and distance are directly proportional. So ratio concept is very useful. Time and work. Ooh, very lengthy question to read. Okay, let's read it together. A civil project was initially estimated to be completed by 150 men in 150 days, each having the same level of efficiency. However, since the actual work output per man was below expectation, only 1/4 of the project was completed after 50 days. If the project head wishes to finish the project 10 days ahead of schedule to earn an incentive, how many additional men of the same efficiency must he employ to meet the target? Very good, right? Incentive. Good. So, what I'll do is I'll quantify the work first of all as 100 units, right? That would make life easy. I'm taking the work to be 100 units, total work. Okay. So, what I will say, 1/4 means 25 units of the work. How much work was done? Initially, 25 units was done, right? In how many days? 50 days. 25 units of work done in, uh, just one second. Just one second. Work is 100 units, right? So how much work was done? 100 unit, sorry, 25 units, 1/4 of the work. In how much time? In how many days? 50 days, right? So how much work is remaining? This was initially work done. Now about the remaining work, what I'm trying to establish over here, try to understand. What I'm trying to establish is the work rate which is required initially vis-a-vis what remains to be done. Rate is work upon time. So what I'm saying, 25 units was done in 50 days. By how many number of men? I'm not worried about that right now. I'm just worried about the effective net work rate. Remaining work is how much? Remaining work is 75 units. Has to be done in how much time? 150 was the target. 50 days are gone. He wants to finish 10 days ahead of the schedule, means his target is 140 days. 50 days are gone. 140 minus 50, 90 days are remaining. So what is his target? 90 days is his target to finish the remaining 75 minutes. What was the work rate achieved initially? 25 by 50. Rate is work upon time. 25 by 50 or half. What is the rate that needs to be achieved now? 75 by 90, which is 5 by 6. 15 into 5, 15 into 6. You can see it's a substantial increase. So from half to 5 by 6, the work rate has increased in what proportion? What is the ratio of the work rate of the initial to the final? The for the remaining, I would say, the remaining work to be done, what is the rate to the initial rate? 5 by 6 is to 1 by 2. 5 by 6 is to 1 by 2, which is 5 is to 3. So if the rate has to become 5 by 3 times, so the number of men also have to become 5 by 3 times. Hence, if 150 men were there, we now need 5 by 3 times of 150, which is 250 men. We need 100 more men to do this job. Straightforward, simple. Compare the work rates, get it done. Right? Compare the work rates. You can then say, okay, in this ratio, the work rate is being increased. So therefore, in this ratio, also the number of men needs to increase. Right? Because work rate is proportional to the number of men. If you double the number of men, your work rate will also get doubled, right? All the men are having the same level of efficiency. Perfect. Okay. So the moral with this question is, now sometimes questions are lengthy but not difficult, right? So do not right. I have kept this question for a very specific reason, to bring out this point. Do not reject the questions only on the basis of their length. Sometimes, so it will take what, 30 seconds more to read, but you will get this question done in 1.5 to 2 minutes also, right? Exam strategy is very important. Next, geometry, right? Okay, so so I'm starting this off, right? Let's see if you can get this. In the figure, ABCD is a square. Figure is there, very good. So geometry question having figures are easier, because at least you don't have to sketch the figure, everything is there. So you can see that lines AM and CN, which are the medians, are drawn. So, right, M is the midpoint of CD, N is the midpoint of AD, intersecting at that point P over there. You have to find the area of this quadrilateral over here, APCB, right? This one. This is what fraction of the area of the square? It very much looks like at least it's more than half, because if I join this AC, obviously this ACB is half of the square. So all the options also you can see are more than half. So that does not help us to eliminate, right? The exam setter knows what people will think. So actually the way to do this question is, the simplest approach is exactly what I just did, which is to join this AC diagonal and say, okay, on one side, at least half of the area is lying on this side. Now I have to only worry about triangle APC. So analyzing quadrilateral, the typical approach is break it into triangles. So join a diagonal, you have two triangles, right? So that is what we will do here. That is the best approach, right? Now coming to this figure over here, right? Two medians are drawn. So two medians will always intersect at their centroid of the triangle. Obvious, right? AM and C and the medians are there. They will be intersecting at P. So P is the centroid of triangle ACD. Now to complete the whole figure, wouldn't it help us if I can just join the third median also, for the sake of perhaps some concept or property of medians and centroid we can use? So why don't I join this DP to form the third median also? Don't mind my line. I'm doing my hand sketching, right? It's not perfect, but yeah, it's a line, right? So, with this, whatever, call it some x, this dx being the third median, this p being the centroid, now comes the property, right? When all the three medians are drawn inside a triangle, then you can see these six triangles being formed. And the property of centroid and medians is that all these six triangles which are formed are equal in area. If you don't know this, you should know this, right? That's a very basic property of these triangles that get found by the medians. And so let me also clarify this property. I'm not saying that these six triangles are all congruent to each other. I'm not saying that. That is not the case, but still they will always be equal in area. So therefore, these six triangles are equal in area. This APC is two out of those six triangles, right? So therefore, this triangle APC as a fraction of the area of the entire triangle ADC is those two parts out of the six parts. So that is 1/3 fraction of the area of triangle ADC. But we have to find APC area as fraction of the whole square ABCD, not of triangle ADC. So what we will say is that triangle APC is 1/3 of the area of the triangle ADC, but area of triangle ADC is half of area of square ABCD, that is just half. So 1/3 of half. So as a fraction of the square ABCD, the required fraction is 1/6. So therefore, the required total fraction of the area of the quadrilateral APCB, right, as a fraction of the whole of ABCD is the half over here, and the 1/6 that we have got from here, half and 1/6 is 2/3. Half and 1/6 is 2/3. That is your required fraction, right? A typical question of geometry, making use of those properties of all those centers of triangle, right? Okay. Next one. So questions have come, a lot of questions have come in recent years on this style. Some equations are there where you have to do curve sketching, right? So area of the region in square units bounded by these graphs. All the graphs you can see are modulus equations. Uh, Very standard ones. All of you should know these equations and their graphs, right? So can I say, since these are modulus equations, so the graph will be symmetric in terms of how I will see them in the four quadrants? Let me sketch this for you. It will become very clear what I'm saying. This being the x and the y axis, right? So let me color this differently so that you can see this clearly. This is x equal to 3. This is x equal to -3. Mod x equal to 3 will be two vertical lines. Mod y equal to 4 will be two horizontal lines. This will be, let's say, y equal to -4. This will be, let's say, y equal to +4, right? So then my point is, you can already see these, right? The graph so far is symmetric in all the four quadrants, identical things you're seeing in all the four quadrants. And likewise, mod x plus mod y equal to 5 is a standard, it's this shape, a kind of a square figure, right, with center as the origin. So right, so the shape is very symmetric. So my point is, this is the area, the entire, let me share this so that you can understand what I'm saying. This boundary, let me make this boundary little bit solid, this one, right, this whole thing. You find this area. So obviously this area, right, bounded with between this horizontal vertical lines as well as the square figure is, I mean, it's exactly the same in all the four quadrants. So you can just find this area and make it 4 times. So I'll just zoom this sketch in the first quadrant. I'll just focus on that and I will quadruple that area, right? Make it 4 times. So just now work with the values, right? Make it identify all the intersections of all the lines and everything. So I'm just now focusing on the first quadrant here now, right? This is my x-axis, this is my y-axis. So I'm doing this, but on this screen. So therefore, it is taking time for me to sketch because of my limitation. But when you are sketching with your free flowing hand, you can do this very quickly, right? Uh, So x plus y equal to 5, obviously, right? Means this is 5 comma 0, this is 0 comma 5, right? And then this vertical line x equal to 3, something like that, x equal to 3, and the horizontal line y equal to 4, right? So basically this area, let me again shade this, right? This area. So obviously that is the area of this kind of almost, this is a square, right? This one, and minus this triangle, that would be easiest to do, right? So this shaded area, so this is obviously a square because no, this is not a square, this is a rectangle, because we have to, this line is x equal to 3, so this is 3 comma 0, so this base is 3 and this line is y equal to 4, this is 4, so this is a rectangle of 3 by 4. So the shaded area in the first quadrant is equal to the area of the rectangle, which is 4 into 3, 12 square units, the whole, and take away this triangle. So I have to find the dimensions of this triangle. So this being y equal to 4 and this being x equal to 3, so this point is 3 comma 4, and this point, this one which this on this vertical line where it meets this right line, so this is x equal to 3 and this is line x plus y equal to 5. This is x plus y equal to 5. So if this is x is 3, so then y is 2. X plus y equal to 5. So x is 3, y is 2. Likewise, this intersection. Why I'm finding these intersections? Because I have to find this base, this height of this right angle triangle. Obviously, this is a right angle triangle, right? Vertical and horizontal lines meeting at a 90-degree angle. So therefore, this being 3, 2, this being 3, 4, this side is 2 length. This side is of 2 units in length. And likewise, this being y equal to 4. So here y is 4, so x is 1. So this is 1 comma 4. So 1, 4 and 3, 4 again are separated by 2 units. So square shaded area is rectangle area, 4 into 3, rectangle area minus triangle area. Triangle area is half into base into height. Base is 2, height is also 2. 4 into 3 is 12, half into 2 is 2. 12 minus 2 is 10. As I said, quadruple this, your answer is 40. Done. So my point is, you should be very comfortable with curve sketching. We have done these kind of questions earlier as well. You have seen them, isn't it? So you should be very comfortable with curve sketching, right? And modulus based equations, you should be very clear with, right? We have done this graph many times earlier. Okay, right? Let's see next one. So I think I have brought some new questions this time because answers have stopped coming, right? So if answers are not coming, that is also good sign because you're learning something, right? Initially, I was getting some answers. Now let's see. So 3fx plus 2f1 minus x is x squared plus x plus 1. Then f of 3 is how much? So what we have to do is, this is a functional equation, right? In which what we have to do, we have to solve for fx. So what we will do, we will try to eliminate, this 1 minus x. How do we do this? What we do, you note this in the expression 1 minus x that is there. If you replace x, with 1 minus x, what you will get? Replace x with 1 minus x, what you will have is, you'll get back x. Because in 1 minus x, if you do that, so 1 minus of 1 minus x is back to x. That's the key. So the point is, in this question, you have to eliminate this f of 1 minus x, for which what you can say is, okay, if I in this, so this equation is true. So in this equation, if I replace x with 1 minus x, I will have another equation of a different kind with different coefficients. And then fx can be obtained, right? So see this. Given equation is 3fx plus twice of f of 1 minus x is this quadratic, x squared plus x plus 1. Replace x with 1 minus x. This is the step. Replace x with 1 minus x throughout. So 3 times f of 1 minus x, which I'm writing here because I want to eliminate this. So I'm writing here, and plus, so twice of f of x. As we know, 1 minus of 1 minus x is back to x. So twice of fx plus thrice of f of 1 minus x. Classic linear equation sort of thing in terms of fx and f of 1 minus x. Is 1 minus x the whole square plus 1 minus x plus 1. Simplify this. You have another algebraic expression, 1 minus x the whole square. So 1 minus 2x plus x square, right? Plus this is 2 minus x. So on the whole, this simplifies to become what? X square minus x minus 2x, so minus 3x plus 1 plus 2, so plus 3. Equation number 1, equation number 2, we have to eliminate our f of 1 minus x. So 2 and 3. So multiply this one with 3, multiply this equation with 2, and then subtract. So 3 into 3, 9fx over here, minus 2 into 2, 4fx. So 5 times of fx, 5 times of f of x. And this will go away, this will become 0. 6f of 1 minus x, 6f of 1 minus x cancels. Equals thrice of this, so 3x square plus 3x plus 3, and minus twice of this, so minus 2x square plus 6x minus 6, right? Is x a square? 3x plus 6x plus 9x plus 3 minus 6, which is minus 3. Done. So this is 5 times of fx. So therefore your fx therefore is this upon 5. Put x equal to 3, you have your answer, right? So that's your answer. F of 3 is therefore 3 square 9 plus 9 into 3, 27 minus 3 upon 5. So this is 27 plus 6, 33 by 5, which is 6.6, right? So 6.6, there goes your answer to this. All right, perfect. Thank you. So with this mood, I hope you will continue with your practice, right? CL Power 30 is a module that you can check out with 15 sectional tests, 15 sessions, 15 CDC mocks. I already told you about CDC 4, right, which is happening on 16th, and tomorrow is the last date, right? And Power 30 is also a module that can help you in the last minute, right? All the best, all the best. Stay in good spirits. That's the best. That's the only thing that you need, right? At this stage, cool mind, right? You know, you have by now known what you need to know, right? Thank you. Cheers. Thank you. All the best.